Good day. We are the group who will present the mini ice plant, and we will perform 3 experiments. I am Nelson Jan M. Alcantara.
I am Mark Paulo Bagi.
And I'm Ramil G. Raguso.
I am Andrew Hill G. Magdana.
And here are the list of our experiments. The first one is determine the cost of ice production with the following brine solution: 10%, 15%, and 20%. For the second one, compare the different brine solution with the use of freezing temperature versus brine percentage diagram. Then for the third one, compare which is more efficient to use an ice mold between the plastic and a metal mold. The group will start with the 10% brine solution. The group will use 10 liters of water and 1 kilogram of rock salt for the first trial. First step is to make sure that the weight of the salt is accurate using a digital weighing scale. And we will put the salt in the ice bucket. The reading should be 500 grams. And add it so it will become 1000 grams. Then, the group will fill up the bucket with 10 liters of water using a 1 liter water bottle. Then, mix it. Then, using a salt meter, measure the percentage of brine solution in the bucket. Make sure that it reaches around 10% for the accuracy of the experiment. Then, the brine solution will be poured inside the freezing tank. The reading of the wattmeter before starting the system is 1128 kilowatt hour.
Tulog si Enson. Ba? Ay, si Bakla! Dito! Sa kabila. Yan yung wow.
So, after starting the system, the group listed the wattmeter reading before operation, the ambient temperature, and the time. The group will monitor the temperature inside the freezing tank every 30 minutes. After 1 hour, the reading of the temperature inside the freezing tank is 10.25 Celsius. Then, we will record it. After 1 hour and 30 minutes, the reading inside the freezing tank is at around 3.75 Celsius already.
So now, our brine has reached the temperature of 0 degrees. In this case, we are now about to place the popsicle mold with the water inside our freezing tank. And now we are going to wait and check it in an interval of 30 minutes. As you can see, the electronic kilowatt meter is now in a reading of 1139.8. In 30 minutes, our bright temperature now is -5 degrees Celsius. And now we are going to check if the water in our popsicle mold has turned into an ice.
Not yet.
As you can see, the water is still in a liquid form. And in this case, we are still going to wait further. After 3 hours, the brine temperature is now negative 6.25 degrees Celsius. And now we are going to check if the ice mold, that the water inside the ice mold has now turned into ice.
Nakapag ano naka-yellow?
As you can see, some have turned, actually about all of them have turned into an ice, but still their texture is like a gel.
Thin ice.
Yeah, a thin ice or a gel-like figure. So we are now going to return it back so that it will turn into a more hard ice. After 3 hours and 30 minutes since starting the system, our bright temperature is now at 6.25 degrees Celsius. And now we are going to check if the water at the popsicle mold have now turned into a hard ice. And it seems that the water inside the popsicle mold is now a hard ice. This is now the water that have turned into an ice inside the popsicle mold. And now we're going to stop the system. As you can see, the reading in our watt meter is at 1,149 kilowatt hour.
So, for the summary, in a total of 1 hour and 37 minutes, the group produced ice using the 10% brine solution. And here are our computation. For the ice production formula, multiply the total kilowatt hour used starting in 0 degrees to the kilowatt hour rate of Meralco. Then divide it by 0.33 kilograms, which is total to 330 milliliter, the amount of water inside the ice mold. Then the total cost of ice production for the 10% brine solution is 230.29 peso per kilogram. For the second trial, the group will use a 50% brine solution. Using the 10% brine solution, the group added another 500 grams of salt so that the brine solution will become 15%. Unfortunately, our salt meter has only a capacity of 12% brine solution, so the group decided to use by-mass method. Then stir the brine solution. The reading of the watt meter before starting the system is 1151.5 kilowatt hour. So, after 30 minutes, the reading inside the freezing tank is 7.25. Then, after 1 hour, the reading inside the freezing tank is 3.25 Celsius.
Now the temperature in the evaporator is 0 degrees Celsius. So now we can put this popsicle mold into this evaporator. And this is the reading in the watt meter, which is important in the documentation purposes.
Okay, 1, 2, 3, go.
And the time is 6:21, so we will write it down in the documentation.
Parts, papatay nga muna. Nasa yung ano natin, yung tape natin.
Then we will wait. Then we will wait for another 30 minutes to check if the popsicle mold, if it's something changed.
After 2 hours, the temperature is now negative 2.5. And now, we will check the popsicle ice mold if the water turns into ice. Not yet. Not yet, so we will wait for another 30 minutes.
After 2 hours and 30 minutes, the temperature inside this evaporator is negative 5.25. And now we will check if the popsicle mold turns into ice. As you see, nothing.
Wala.
Wala. And wait for another 30 minutes to check if it changed to ice. After 3 hours, the temperature inside this evaporator is negative 7 degrees Celsius. Now we will check if the popsicle mold, if it turns to ice. Nothing. But some are turning to ice already. But just a jelly one.
At 3 hours and 18 minutes, the water of the popsicle mold have completely turned into a hard ice. This is the ice that was made in the freezing tank. And the temperature of the brine in that freezing tank is now at negative 8 degrees Celsius.
So, for the summary, in total of 1 hour and 52 minutes, the group produced ice using the 15% brine solution. The computations are the same. Multiply the total kilowatt hour used starting in 0 degrees to the kilowatt hour rate of Meralco. Then divide it by 0.33 kilogram, which is equals to 330 milliliter, the amount of water inside the ice mold. Then the total cost of ice production for the 15% brine solution is 275.33 peso per kilogram. So for the third trial, 20%. So the procedure is the same. Just add 500 grams of salt to the existing 15% brine solution.
The plant, we will mix this 500 grams of salt to the water so that the brine solution will become 20%. Then we will use a bucket, this bucket to drain the water inside the freezing tank. So here's the freezing tank. Here's the water. The brine percentage of this solution is 15%. So let's drain the freezing tank. ko. Nangubat na USB. Then, we'll mix the 500 grams of salt. Then, stir it. So, after mixing, we will put back the brine solution, which is 20% now. Okay. Then plug the ice plant. The wattage, the temperature of the ambient and the temperature inside the tank will be specified, the initial values of it. Step, turn on the ice plant. Make sure the water is flowing through the cooling tower. As you can see, it is flowing. Then turn on, upload the Arduino program. That is the temperature inside the freezing tank, 20.25. Then we will wait for 30 minutes to cut down the temperature difference, and that's it. We'll wait. After 30 minutes, we will check if the brine solution produce ice. Then we see that no ice was produced. So we're gonna plot the temperature inside the freezing tank. The temperature inside is 15.25. So we're gonna plot it. Okay, then wait for another 30 minutes. So after 2 hours, more than 2 hours, the temperature inside the freezing tank is 0. As you can see, the temperature inside the freezing tank is 0. So we can put now the ice buckets inside the freezing tank. This is the freezing tank temperature. So this is the freezing tank. Then we will put this ice. We will put now the ice bucket inside the freezing tank. Then wait for it to freeze. The time, the kilowatt hour will be listed for the documentation purposes. At around 3 hours and 30 minutes, the temperature of the freezing tank is -10 degrees Celsius. Then the ice is starting to form already. So we wait for a couple of minutes. So after 4 hours, the temperature inside the freezing tank is, as you can see here, is -11.5. Then this is our documentation, -10.25. So then the ice mold inside is already ice. Then we open it. It's so hard.
Candy.
Then we completed our task. So, in our documentation, we start at 1011 kilowatts. Then, this is the reading at the watt meter.
Tol, magyayabang ko lang ito.
1120. Okay. That is our experiment for today.
So for the summary, in a total of 1 hour and 49 minutes, the group produced ice using 20% brine solution. The computations are also the same. Then the group got the total cost of ice production for the 20% brine solution is 262.82 peso per kilogram. For the second experiment, which is to compare the different brine solution with the use of a freezing temperature versus brine percentage diagram, the group used the data of the first experiment and we observed that different freezing point was affected due to the different amount of salt mixed with the water. Let's start with the 10% brine solution. After around 2 hours and 17 minutes, the temperature inside the freezing tank is -4 and the ice was starting to form around the evaporator coil. Then, in the second trial, which is 15% brine solution, around 2 hours and 40 minutes after starting up the system, the temperature inside the freezing tank is -6.25 and the ice was starting to form around the evaporator coil. Lastly, in the third trial, which has 20% brine solution, the ice was starting to form around the evaporator coil with a temperature of -9.5 Celsius after around 3 hours and 25 minutes. So here's our diagram. So the summary is that the freezing temperature for 10% brine solution is -4 Celsius, for 15% is -6.25 Celsius, and for 20% is -9.5 Celsius. So for the conclusion, a brine solution has a lower freezing temperature because salt disrupts the dynamic equilibrium. Salt doesn't easily bond with the water molecule in the solution, which decreases its freezing temperature.
And now we are going to start our third experiment. The water that we are going to place inside our plastic mold and metal mold is measured at 330 ml. The one that is Johnny is holding is the plastic popsicle. And this one is the metal mold that we are going to use to prepare for our third experiment.
And the power reading the ice plant is 1187.4 kilowatts.
And then we will wait for the freezing tank to be at 0 degrees Celsius. Here is the reading. The reading now is exactly at 0 degrees Celsius. So we will put now the 2 ice mold. Then we will wait for it to become ice.
For every 10 minutes we're going
We'll
to
record.
record the data that the Arduino serial monitor will contain. Our brine solution is at 15%. Here is a proof of it. As you can see, the measurement read by the salonometer is at 13.99. This means that it has even exceeded its safety factor of since the solenometer has a limit of 12%. As of now, at 30 minutes, you can see that the water inside the ice can, that some of it have turned into an ice. As for the plastic can, is still all water. By this, we can already prove that the ice can is more efficient to use than the plastic container. After 40 minutes from placing the ice can and the ice molds from when the brine solution reaches 0 degrees Celsius, you can see that the water at the ice metal can had now turned into an ice. Some of it is still water, while the water at the plastic mold, a few have turned to an ice, but most of it is still water. The temperature is at negative 7 degrees Celsius. We are now at 50 minutes and the temperature is negative 7.75 degrees Celsius. As you can see, there's still some water that can be found in the ice water can. Meanwhile, the plastic mold some of water still. They have not completely turned to an ice. As you can see, there's still some liquid water left that haven't solidified. Same as in the can, metal can. So we're going to wait for a few minutes more, waiting for which one of these two would the water solidify completely. Now we are at 70 minutes. The temperature is still same as when it was 60 minutes. Negative 8.5 degrees Celsius. As you can see, there's still some water in the metal ice mold can. While with the so cold. Plastic mold. It seems that our initial conclusion was wrong, that the ice metal can is more efficient but there's still few water that can be seen with the plastic mold. But most of it is mostly solid already. We put it back and wait for it to completely solidify. This is now at 80 minutes. The temperature is now negative 8.75 degrees Celsius. As you can see, the water have reduced significantly because some of it have already solidified. And as for the water in the plastic mold, as from the outside view, seems that all the water, we can still see that some water from the inside, there's still some water from the inside. But more or less, the plastic mold is more efficient than the can 1. Might be because of the plastic container having small containment of water than the ice can with a single containment. This means that the plastic container has a lot of surface area for it to have a heat exchange. And so we will still bring it back inside the freezing tank and wait for a few minutes. Minutes of the experiment. The ice can still have a few water left that haven't turned into an ice. Let's see how the plastic mold does. It seems that the plastic mold, all of the water inside the mold have now solidified into an ice. So in short, as we have said a while ago, the plastic have been more efficient than the metal mold.
Mabas na ba?
At 110 minutes, the water inside the metal mold but have turned into an ice, but still some of it are liquid. There. So now we're going to turn off the system. First, press the emergency stop. Turn the button off. Now we're going to get the power rating. It is at 1199.7. So we are done with our experiment.
As a summary, the ice was produced first in the plastic mold for only 90 minutes and 110 minutes for the metal mold. It was seen in the early minutes that the metal mold seems to be more efficient than the plastic mold, but when time passed by, all water inside the plastic mold have turned to ice faster than the water inside the metal mold. This may be because the plastic mold have more surface area for heat transfer than the metal one.
We are now trying to remove the ice that was formed inside the metal ice mold. This is the ice that was formed inside the metal ice mold.